To configure the element identification parameters, select this shortcut button in the toolbar. The element identification configuration screen will then be displayed. The upper part of the screen displays a representation of the periodic table showing all the elements for which characteristic emission lines are included in the reference database and which libsoft can therefore be used to identify. Each element has two buttons associated with it, one labelled with the element symbol and one that is unlabelled. The labelled buttons are used to select the elements that will be included in the analysis. The unlabelled button for each element is used to specify the element selected for display, i.e. the one for which the characteristic emission lines and map data, if any, are displayed in the main window of the module. As you can see, only one element can be selected for display at any one time. In the middle of the screen are the mapping configuration parameters. Note that these parameters are only applicable if the element identification module is used to map data acquired from different positions on a sample. The element ID mapping functions are described in a separate video. The parameters, though, are as follows. The crater diameter. This is the size of the marker used in the maps to represent the approximate size of the crater on the sample surface created by the interaction of the laser with the sample material. Spot diameter. This is the size of the marker used in the maps to represent the approximate size of the laser spot on the surface of a sample. Note that the crater and spot sizes are intended to be indicative representations only, so that any likely overlap between analysis sites can easily be identified from the maps. The actual sizes will vary depending on the experimental conditions and the samples analysed, and it is up to the user to set these values appropriately. The emission line wavelength. This parameter allows the user to select which of the primary characteristic emission lines for the currently selected element should be used to generate the intensity map. Lock intensity range. This parameter allows the range of intensity values used in the intensity map to be locked when changing the spectrum number to map, instead of updating the range based on each new spectrum. This can make it easier to see variations between spectra. The use of these parameters will become clearer in the videos describing the identification and intensity maps. To the right of the mapping configuration parameters is a checkbox to allow online identification to be selected. This checkbox is only enabled if a suitable spectrometer has been detected and initialized by libsoft on startup, i.e. the system is capable of acquiring spectra. Online element identification is described in a separate video. At the bottom of the screen are the analysis configuration parameters. These parameters are as follows. Peak match tolerance. This is the range of wavelengths centered on the reference emission line wavelength in which the analysis software searches for a candidate peak. Peak window. This is the interval either side of the candidate peak in which it must be a maximum to be defined as a peak. Reference window width. This is the interval either side of the candidate peak in which the analysis software searches for the limits of the peak, i.e. the minima either side of it. Signal baseline ratio. This is the minimum value of the ratio between the peak intensity and baseline intensity either side of the peak for it to be deemed valid. Minimum intensity. This is the minimum intensity of an identified peak for it to be deemed valid. Wavelength shift. This parameter allows a linear wavelength shift to be applied to the spectrum to account for a shift in the spectrometer calibration. Spectrum type. This allows the spectrometer used to acquire the spectrum under analysis to be selected, and thus automatically select the analysis configuration parameters suitable for that type of spectrum. Note that the identification process is automated based on the configuration parameters set here. In the majority of cases, the default configuration parameters can be used very successfully, but the user can tailor these as required. This button will restore the default analysis configuration parameters for the currently selected spectrum type. The definition and use of these parameters will become clearer in the video describing the reference emission lines. In the bottom right-hand corner of the screen, there are additional controls to help with the analysis configuration. These are as follows. Element. This control allows the user to enter the chemical symbol for an element directly instead of selecting it in the periodic table. Doing so will toggle the selection state of that element. So if we enter aluminium, aluminium is there included in the analysis. But if we enter, say, hydrogen, hydrogen will then be deselected. Select all. This button will select all elements in the periodic table for inclusion in the analysis. Select none. This button will deselect all elements in the periodic table from inclusion in the analysis. Load configuration. Opens a file browser to allow a saved configuration to be selected and loaded for use. Save configuration. Opens a file browser to allow the current configuration, including the element selections and both mapping and analysis configurations, to be saved for later use if required.